All right, good morning. This is Mr. Sala. Just going to go over a couple of things, a brief overview again of transcription and translation. Then we'll look at the codon wheel, and then we'll get a little practice looking at transcription and translation. So, right in chapter 10, section, this would be section 4, protein synthesis. There's a very good picture at the bottom of 204 for you to visualize what is going on. Again, the central dogma going from DNA to RNA to proteins. So again, we talked about DNA is such a large molecule. It's locked up in the nucleus. And then how do we get that message? How do we get those genes, the instructions from the genes out to the ribosomes to build a protein? All right, so the first part is transcription. So you've got to transcribe a section of the DNA, which we'll call a gene, and you've got to get that coded into messenger RNA, which is now small enough to go through the nuclear pore and get it out to the ribosome. And then from there, that's where translation will take place. So this mRNA, which is also called a codon, can go ahead and then start coding for specific amino acids, which are the building blocks of protein. So again, we're going to break down each of those parts as we make our way through this process over the next week. But we're going to go ahead and practice actually transcribing and then translating that into those amino acids. So what you have here is you have, say, a segment of a gene, segment of DNA that codes for a specific protein. So you're going from DNA to mRNA, and remember when you're with RNA, thymine is replaced with uracil. So you've got to remember that as we go through with the complements. So adenine here, again, if it was DNA to DNA, would pair with thymine, but it would pair with uracil, so you would put a U here. Thymine still pairs with adenine, and then guanine still pairs with cytosine. And then if you look at the next set, remember each three-letter sequence is a codon. So I like to draw the lines just as a matter of bookkeeping. You can do the same. We'll go through a couple more. So then you look at G, G, and G. So again, those all are still going to pair with C, C, and C. And then again, adenine pairs with uracil, guanine pairs with cytosine, and then again, adenine pairs with uracil. All right, so now we've taken our segment of DNA, say a gene, and transcribed it into the mRNA, which is also called a codon. So then we can go ahead to our codon wheel and then get our amino acid for each of these codons. So here is the codon wheel. Very easy to use versus the old school first base, second base, third base. So I'm only going to teach it this way here. So again, the letters are the largest in the middle, so automatically your eyes should be drawn almost to the center here. And then you're going to look at the first letter that you have in your sequence. So I have U, A, C. So then if I go here, I'm going to look at the U. Then I'm going to go to this next level and then the third level. So we had U, A, C, which is tyrosine, which you're only concerned with the three letters here. So then you would just go back and put your T, Y, R. So your first amino acid would be T, Y, R. Now remember, this is practice. So normally what would happen is when you started an amino deciphering the codons, you would actually start with methionine, which would be AUG. That would be your start codon. And then again, if then proteins can actually be from hundreds to thousands of amino acids long, and then you have 3 stop codons that are over in this area, UAA, UAG, and then UGA are your 3 stop codons. But remember, this is just practice, so we're just really trying to go from the DNA to the mRNA to the protein. So our next codon was CCC, so we can look to see what that is. So CCC is proline, which is PRO, so then we would just write that amino acid right here. And then we'll do one more here. So again, DNA to the mRNA codon. Now we go to our codon wheel, so UCU, you go UCU is serine, so that would be SER. All right. Hope that clears everything up. If you have any further questions, go ahead and shoot me an email, and have a great